Greetings, mathematicians, and welcome to Moving Straight Ahead 4.1, 4.2. Today we are talking all about slope, and I'm going to show you how to find it in a bunch of different situations today. Our focus question describes those situations. How can you find the y-intercept and the slope of a line from data in a table, graph, or an equation? Before I show you the different methods, let's review some important vocabulary here. So we should already know the definition of a y-intercept. This is the point where a line crosses the y-axis. Right, and we in our previous lessons, this has usually been represented by our starting point or starting values. Okay. What we also know about this is that the coordinates for the y-intercept are always going to be 0, comma, and I'll say b. The x-coordinate for the y-intercept is always going to be 0, and then the y-coordinate is going to be wherever the line crosses the y-axis. Okay, so this is review. Let's talk a little bit about slope-intercept form. This is the equation that we've come to know and love, y equals mx plus b, right? And we have to review a few of the main parts here, where m refers to our slope or our rate of change, and b represents our y-intercept. Okay, and today finally we're going to be talking about this word slope. Now, if we think about slope, well, the definition that I'm going to give you, or at least a part of the definition, is well, when somebody asks you what the slope is, you give them a number, and this number tells you how steep a line is. So we're gonna put this as a part of our definition. The slope tells you how steep a line is, okay, and we've actually seen a bunch of different situations with different types of slopes. We've seen a situation with a positive slope, or a positive rate of change, I should say, a negative slope. We've also seen fractional slopes, so slopes that are fractions. We've seen zero slopes. We're going to define all of these a little bit later on, I think when we get into 8th grade math. But for now, the slope is, well, what does it do? It tells you how steep a line is. So the bigger your value is for your slope, the steeper your line is. What I also want to add to this, and here we're going to get a little bit more mathy and technical. We define the slope as a ratio between the change in y, I'll explain this in a little bit, change in y, and the change in x. And I'm going to add some things in parentheses here. So change in y, we could also refer to this as vertical change. And then change in x, we'll refer to this as horizontal or sideways change, right? Make sure you understand the difference between a vertical and horizontal, please. All right. And typically when we write the ratio of slope, of slope, I guess, right? Yes, when we write the ratio that is slope, you're always going to write it in this order. You're going to include your vertical change, and you're going to write that over your horizontal change. So when you're writing your slopes, this is the order in which you have to write the ratio. If you do not write it like this, you will not get the correct slope, so be very careful. There are other ways to think about this. actually, let me define this as slope. So slope is vertical change over horizontal change. Fancier way you could write this is add a little triangle. Little triangle is the Greek letter for delta, which stands for change. So I say the change in y over the change in x. You could say delta y over delta x. And then the last way I'm going to write this is in words. So change in y over the change in x. And again, I really have to stress the importance of the order in which you write this ratio. Because remember, when we write ratios, does the order matter? Yes, it does. And I'm telling you the order of this ratio is vertical change to horizontal change. Okay, so please keep this in mind. Repeat it as many times as you need to so that way you remember this. Alrighty? So with that, let's go ahead and take a look at what slope is in terms of the graphs, the tables, the equations. Okay, you should have printed out a lab sheet that looks like this, and we're going to go over each of these problems here. Alrighty, take a look at the first section here. They want us to find the slope, the y-intercept, and then write the equation. So at the very top, I'm going to write down y equals mx plus b, just so I have it here for reference. Okay, my m represents my slope, my b represents my y-intercept. And that's what's so nice about this form that we're writing linear equations. Because if you find the slope, if you find the y-intercept, you have yourself an equation. Well, you can write an equation from those two pieces of information. Okay, so let's take a look. To find the slope from a graph, remember, we're looking for horizontal change and we're looking for vertical change as well. So my suggestion is find 2 points on this graph. So I'm going to take a look. I'm going to zoom in here. I see the graph goes through this point and it goes through this point here. Okay, so once you find your 2 points, you can find the vertical and the horizontal change between the 2 points. So let's start off with the vertical change. So starting, so let me stay in red. So starting here, starting at this point at -1, 9, I'm going to travel vertically down to the line where my next point is. So in this case, my vertical change, how many spaces did I go down from 9 to 6? Well, I went down 3 units, right? I went down 3 units from 9. That is what I'm going to describe as my vertical change, or my delta y. Now, remember, the other part of the ratio is the horizontal change. So I go from here to the point that I am looking at. How many did I go over? I went 1 to the right. And when you move to the right, folks, that's a positive. It's a positive one. If you move to the left, that's actually a negative, okay? So if you move down or left, that's negative. If you move up or right, that is positive, okay? We're gonna keep practicing this, so don't worry, you'll get the hang of it. So I have found my 2 pieces of information I need for the slope. This is my vertical change, this -3. This 1 is my horizontal change. Did I say negative change? No, vertical change is delta y is -3, and horizontal change is 1. All right, so when we write the slope, remember, the ratio is the change in y over the change in x. And we found both of these values. We said that my change in y is -3, my change in x is 1, so my ratio is -3 over 1. Can we simplify this? Yes, we can. Yes, we can. So my slope, remember my slope is m, is just -3. All right, now we need to find the y-intercept. Well, remember the definition of our y-intercept is where does the line cross the y-axis, and that just so happens to be here at the point 0, 6. There's really not much work to show there other than locating it on the graph. Okay, so now that I have the 2 points that are necessary to write the equation, I can go ahead and plug these into y equals mx plus b. So I plug in -3 for m, and then I plug in 6 for b. So my equation is y equals -3x plus 6. You can definitely check your work using Desmos. Type this equation into the graphing calculator. It should look very similar to the graph we have here on this lab sheet. Okay? Alrighty. We're going to try this again. I give you a graph, and your job is to find the slope and the y-intercept. Pause the video, try this on your own, and then resume playing and I'll walk you through it. Alright, hopefully you pause the video. Here we go. Remember, I suggested that you find 2 points on the line. So I'm going to do those in green here. It can be any 2 points on the line, it doesn't matter. Whatever you prefer. So I'm going to go there at -2, 0, and let's go here at 0, 6. Okay, now once you have your 2 points, find the vertical change, find the horizontal change. So I'm starting here I made a little olive there. And I'm going to count how many units do I go up until I reach the line where my second point is. So this is 1, 2, 3, 4, 5, 6 units up. So that is going to be my vertical change, my change in y. And then I need to count how many units over until I reach my second point. So I count 2 units, and this is my change in x. Now, when you write your slope, and I highly recommend you write this down every single time, change in y over change in x. Again, the order in which you write this ratio does matter, so this is important. Alrighty, and then we just substitute our values in. For change in y, we got 6. For change in x, we got 2. And then, of course, you can simplify. 6 divided by 2 gives us 3. And there we have our slope. Let's find our y-intercept. And again, on graphs, it's pretty straightforward. Just look at the point where the line crosses through the y-axis, and this point is 0, 6. And then we can write our equation. Remember, we're using this slope-intercept form, right? We find the slope, we find the y-intercept, and then we just plug in those values. So our slope is 3, our y-intercept is 6. So our equation should look like this. It looks kind of familiar. Kind of looks similar to the first one. We'll talk about this next lesson. Anyway, let's keep going. We got to talk about tables. Alrighty, so tables work very, very similarly. Right, we need to find the vertical change, we need to find the horizontal change. If you keep this fact in mind, folks, there's going to be less chance for mistakes. Okay, so remember, we're always looking for the horizontal change, we're always looking for the vertical change, and then we just write our ratio. Okay, so this rule applies to any situation, any linear situation. Let's take a look at how we do it. Please notice how they wrote their table. The x values are on top, the y values are on the bottom. This is probably one of the most common traps that students fall into, okay? Because when we find the change in x, it's going to be written on the top, and when we find the change in y, it's going to be written on the bottom. But you're not gonna fall for this trap, because you're gonna say, oh wait, it's supposed to be change in y over change in x, so I'm gonna rewrite my ratio. So let's take a look. To find the change in x, all you gotta do is analyze the x values in the table. So as I go from -6 to -4, what is the change? Describe the change. Well, it looks like I added 2. I'm gonna check again just to be safe. -4 to -2 is also adding 2. It looks like -2 to 0 is also adding 2. And hey, this looks good. So this add 2, this plus 2 is going to be my change in x. So my change in x is going to be +2. Now let's analyze the y values. -10 to -7. Looks like I added 3. Let me just double check. -7 to -4, that is also adding 3. And one more for good measure. -4 to -1 also gives me that, or the change is also adding 3. So I think it's safe to assume that our change in y is a +3. Now remember, we're going to write this down. Your slope is always going to be change in y over the change in x. Don't fall for this trap, please. The change in y is 3. The change in x is 2. And so we conclude that our slope is 3/2. And I like to stress the importance of leaving your slope as a fraction, even if it's improper. That's totally okay. I find it easier to graph things when slopes are given in fraction form. So it's okay to leave it as 3/2 for right now. Okay, let's talk about finding the y-intercept. Sometimes you're lucky and it's given to you in the table. All you have to do is remember, well, what are the coordinates of a y-intercept? Remember that y-intercepts are always going to have the x-coordinate of 0. Do we have that on this table? Yes, we do. Look at that. We have an x is equal to 0 here, so automatically this -1 becomes our y-intercept. Don't believe me? Check it on Desmos. Graph it, please. I promise it's the y-intercept. So our y-intercept is 0, -1. We found our slope, we found our y-intercept. Now let's write our equation. So y is equal to 3/2 x minus 1, because we have a -1 here. You could write plus -1, but -1 is a little bit more straightforward. Okay, but just know that they mean the same thing. Alrighty, try the second table on your own. Please pause the video and then replay when you're ready to go. Alright, hopefully you paused the video. Let's go ahead and take a look at, let's find our horizontal change, let's find our vertical change. So as we go from 1 to 2, that's adding 1, 2 to 3, that's adding 1. It's safe to say that I think the change in x is 1. Let's analyze the y values. 4.5 to 4.0. It looks like I'm subtracting 0.5 from 4 to 3.5. Same thing, I'm subtracting 0.5. Yep, I think it's safe to say that our change in y is equal to -0.5. And that's important. Make sure you have the symbol, the positive or negative symbol on there. I mean, for positive numbers, you don't need the positive symbol, but for negative numbers, please put the negative symbol. All right, and we're writing our ratio, change in y over the change in x. Don't fall for this trap, please. The change in y is -0.5. The change in x is 1, and we simplify it. Anything divided by 1 is itself, so our slope is -0.5. It's okay if we have decimals as our slope. That's fine. Like I said, I like to keep things as fractions just because it's easier to graph. However, in this case, we're just looking for slope and y-intercept, so that's not it's not a super important detail at this moment. Okay, so I hope you noticed that our y-intercept is not given on this table. So it's important for us to remember that this is a linear relationship, and we could continue this relationship on to infinity, right? Well, we could also work backwards here. We're not given an x-coordinate of 0, so what we end up having to do is, well, we just actually need to go back 1, right? We need to create that coordinate. Well, how do we do it? Well, if we're moving forward, if we're increasing by 1 each time, if I'm moving backwards, I should be decreasing by 1, right? And that'll give me my coordinate of 0. And so I do the same thing with my y values. When I move forward, I'm subtracting 0.5. If I move backwards, I have to do the opposite, and I'm going to add 0.5. So it looks like my y-intercept is at the point 0, 5. Don't believe me? Graph it on Desmos, please. 0, 5. Let's write our equation here. Y is equal to negative 0.5x plus 5. And there we have it. All right, and the last type of problem here. Oh wait, before we get into the last type of problem, I'm sorry. In your practice, you will see questions that are asking you to find the slope between 2 points. Please be mindful that in order to find the slope between 2 points, it's exactly the same as finding the slope finding the slope from a table, right? So for example, I'll highlight in blue here. I would give you the point 1, 4.5 and 2, 4.0. Find the vertical change, find the horizontal change, write your ratio, and that is your slope. It works the same exact way. So when you arrive at that question in your practice today, just treat it like a table, okay? All right, let's move on to the last type of situation, folks. Sorry, I know my video's, it's getting a little bit long. I'm at 22 minutes. All right, equations are the most simple. Remember that our equations are set up y equals mx plus b, where m, the coefficient of x, is always going to be our slope, and b, this constant over by itself, this is going to be our y-intercept. Okay, so if you can identify these things, you can definitely write your slope and your y-intercept. I keep leaving that out. So let's take a look. In equation 1, the coefficient of x is 2.5, so I can automatically assume that my slope is 2.5. And then, is there a number just kind of floating off on its own? Yes, there is. That's 5, and that's going to be my y-intercept. So my y-intercept is going to be at the point 0, 5, and that's the equation that comes out. So simple and straightforward. Find the coefficient of x, that's your slope. The constant term, the number that's just hanging out by itself, that's your y-intercept. So let's do it again. Pause the video, try it on your own, and then replay when you're ready to go. All right, hopefully you pause the video. The coefficient of x here is this minus 3, so my slope is going to be negative 3. Then the constant term, or the number that's just hanging out by itself, is 20. So my y-intercept is going to be at the point 0, 20. And our equations match. And there you have it. That's how you find the slope and y-intercept in these 3 situations, from a graph, from a table, and from an equation. All right, folks, that's all I have for you today. If you have questions, please come see me during office hours, and I will be glad to help you out. Alrighty, I will see you in the next lesson.